Hi friends, welcome to another session of Java programming. And today's topic is a program to check whether the given number is prime or not. In mathematics, a prime numbers are the whole numbers greater than 1 that have only two factors. Those are 1 and number itself. So you can define the prime number as a prime number is divisible only by the number 1 and itself only. Some of the prime numbers are 2, 3, 5, 7, 11, etc. Prime numbers has got so many applications in computer science. One of the primary application is in RSA algorithm in cryptography. We use prime numbers widely to calculate public and private keys. And in another algorithm called Diffie-Hellman key exchange in cryptography, we use the prime numbers for calculating the hash codes. Okay, so coming back to the program. So look at this particular program here. So the name of the main class or the driver class is prime test here. Okay, here this is the main method. We have defined a scanner object, that is SC, to read some input number. So we are asking the user to enter a number for primality check. So you can enter any number. Okay, so that number will be read into the a variable called p here. So int p equals to sc dot next int will read the number into p. Then prime p is the method call. Okay, so that you're calling a method called prime. So when you call the method prime, you'll go to the method definition, that is prime here, so which is defined as static void prime. So p is the number that you entered or that you passed to that prime method. So you're checking that. Okay, so you know that, okay, I have already told you that number 1 is considered as not a prime number universally. Okay, so we're checking for that condition. If p equals to 1, system.out.println, we are just telling that 1 is not a prime number, right? So this return will close the program execution. And in another case, if the p is not 1, then we are checking if p is less than or equals to 3. In that case, other than 1, that is 2 and 3, those will be considered as the prime numbers. So if you give a p as 2, it tells that 2 is a prime number. If you give a p as 3, it tells that 3 is a prime number. Okay, so in that case also we just close the execution with the return command. If that number is larger than 3, then we come to this for loop here. So in loop, what you're doing is we have taken I as a loop variable, which is a value 2. Okay, I will just show you that. So I is 2 here. And here you can see that we are checking a condition called I less than or equals to math.sqrt of p. Okay, so what is this condition is actually, so we want to divide our number, that is p, with I, and we need to check whether that remainder is 0 or not. Okay, if your number I divides the given number successfully, then I'll say that that number is not a prime, because that other than 1 and number itself. Okay, so in that case we'll say that that number is not prime. In all other cases, so we try to see whether I divide that number or not. Okay, so what is this condition I less than or equals to math.sqrt of p? Okay, so there is no need to check the entire number, that is until p. Okay, so only you need to check the square root of the given number. Okay, so if that I is less than or equals to square root of the given number, okay, so in that case, if that divides successfully, we'll say that that is not a prime number. If that does not divide, we can say that is a prime number. Okay, so we can reduce the number of iterations of this for loop by using this condition math.sqrt of p. Okay, so when you enter a value which is greater than 3, for example, I have entered a number for primality check, that is a 9. So p is a 9 here. So when I call my prime method with the p value as a 9 here, okay, so we'll check what happens. When the for loop first time enters into this for loop, okay, so now my I started with 2, okay, that is true. So I less than or equals to math.square root of p. Okay, what is the square root of 9? That is 3, right? So 2 less than or equals to 3 is true. Okay, so we enter here. So in if condition, we divide the number p with 2. So p mod 2 means 2 will divide 9 4 times and the remainder is 1 here. So 1 equals to 0 is a false. Okay, so we don't go into the body of the if condition. Okay, so where you'll go, we directly goes to I plus plus here, right? I plus plus. Okay, so in this case, so I will become a 3 now. So 2 will become 3 now, right? So we'll come back to the condition 3 less than or equals to square root of 9, which is nothing but 3. So 3 less than or equals to 3 means again that is true. Okay, we'll again enter into this body. Now P modulus divided with I value, that is 3. So 9 mod 3 will give a remainder as 3 because 3 divides 9 3 times and the remainder is 0. So 0 equals to 0 is true, and I say that system.out.println p means 9. 9 is not a prime number, and we just close the execution, that is written, right? So this is how your number 9 is printed as a not a prime number. Okay, so we'll take another number, right? So we'll take another number, something like this. For example, so I have taken a number called 7 here, right? So 7, just to see this. Okay, my I started with 2 here. Okay, so when you first time enter into the follow up, okay, so I is 2. 2 less than or equals to square root of 7. Okay, so square root of 7 is nothing but some 2 point some value will be there, a fractional value. Okay, so 2 less than or equals to 2 point something will give you a true value. So you'll come back here, right? So p mod I, that is a 7 mod I. So 2 divides 7 3 times and the remainder is 1 here. So 1 equals to 0, which is a false. Okay, so we don't go into the body of the if condition. We'll directly go to the I value, that is a 3 now, right? 3. So again we'll come back to the if condition, the condition in the for loop, that is I less than or equals to math dot square root of p, which is a 3 less than or equals to square root of 7, which is a 2 point something. So 3 less than or equals to 2 point something will become a false now. Okay, we'll just come out of this for loop. Okay, we don't go to this if condition, we'll just come out of the for loop, right? So what is immediately after this for loop? So we have come to this place called system.out.println. I'll say p is prime number. So p is nothing but 7 here. So I'll get a value 7 is prime number. So in this way, this program will work. Okay. So now we'll move on to the execution part. Okay, compile the program. Java prime test.java. So my program successfully compiled and I want to execute my program Java prime test. So enter a number for primality check. Okay, so I'm just entering value 9 here. We'll just see what is the result here. So 9 is not a prime. You can see that 9 is not a prime. Again, I'm executing this program. So I want to give number 7. Okay, you can see that 7 is a prime number. Okay, I want to again execute this. Okay, I'm just entering a value 1. Okay, I already told you that 1 is a universally, it's not considered as a prime number. So 1 is not a prime number. So you can see that that is on the screen. 1 is not a prime number. Okay, again we'll check that whether those numbers 2 and 3, whether they are prime or not. So I'm again executing the program. So I'm just entering the value 2 here. And you can see that 2 is a prime number. Okay, again I'm executing the program. And enter a number for primality check. So I'm entering 3. You can see that 3 is a prime number. Okay, so again I want to execute my program. I want to give a number called 27. Okay, and it's telling me that 27 is not a prime number because 27 is divisible by 3 and 9, right? So this is a program to check whether the given number is a prime or not. Hope you understood the concept. Hope this video is helpful for you. Thank you for watching the video. Bye.